Hey everybody, welcome back to the channel. I'm sure you read the title, and yes, today we're going to make a left-hand tap from scratch. From scratch I mean out of this hardened and ground high-speed steel blank that I bought from Amazon, and the seller claims it is 61 to 63 Rockwell, which is just about perfect for a high-speed steel cutting tool. As we quite often do, I'm going to start by putting center holes in both ends of this. And I'm going to put the center holes in using this center drill, this Pursad little center drill. It's solid carbide, it'll do the job. I've already managed to break one end off of it, so let's hope the other end has two good center holes left in it. When center drilling, I always find it's best to start in really easy, really gently, let it find its happy place on center. Don't just go pounding in there, because you can create a wobble and that delicate little tip can just break right off. There's our center holes in our piece. We're going to move on to our next step, which is roughing out our shank and our actual cutting diameter area. If you're into these tool and cutter grinding videos, consider subscribing so you don't miss our upcoming tool and cutter grinding videos. I've got this solid piece of carbide that I ground a 60-degree included angle onto, and that is for one of my center holes. This little thing clamps onto it, and that will drive my drive dog. Before we get going though, I threw my dial on it. I wanted to see how it was running, and although it was all made in this machine, it's not running perfectly true, and I really want it running perfectly true so that I don't have grief with other steps farther down the road. So I'm going to swivel my work head to 30 degrees, and I'm going to give that a quick lick with the diamond wheel, and then she'll be running perfectly true. I'm going to give this thing a quick lick now with the diamond wheel. I'm only taking half a thou off, so I didn't bother to slow my wheel down. I'm not worried about it because we're doing so little work, it's not going to hurt the wheel. I didn't dial my wheel in for the exact same reason. I just want to get this thing running true as quickly as possible, and so I skipped those normal precautions that I would take if I was doing any serious amount of work with a diamond wheel. So that's done. She's running bang on true now. I've got my work head dialed back in true to the table. I've got a nice coarse 60 grit wheel here. We're going to rough the shank down, and I'm going to make a setup to do that, and then I will bring you guys back in and explain the setup once it's made. Pretty much ready to start roughing down the shank here. I've got, like I said, a nice coarse wheel in there. It'll cut pretty coolly, it'll cut cool pretty quickly as well. I've got a stop set up. This area here is going to be my cutting area where the teeth go, and from here down is going to be the shank area. And I've got my drive dog set up on here, and although we're perfectly dialed, I dialed everything within an inch of its life, but what we are going to find, no doubt, is that when I get this thing cleaned up all the way, it's going to have a slight taper. So what I'm going to do is I'm going to rough it down in sides. I'm going to keep an eye on its diameter and its taper. Well, before I get too small, I'm going to switch to a fine wheel for finish grinding. I'm going to clean it up with that. Then I can get very accurate measurements on its diameter and the taper. And then I can use my dial and this table here that rotates to get that taper completely out of it so we have a nice straight shank. I've got my shank all roughed down now. I've got some material left on there for finishing. Now I realized previous me said I was going to rough the shank and then finish it, but current me thinks the best practice would be to rough the shank, rough the cutting area, and then go back and finish both areas. So that's what future me is going to do. I'm going to bring this area down about 5 thou over finish size. That should let me clean up any non-concentricity that develops during the roughing here. Just about set up for finishing here. I've taken out my 60 grit wheel that I roughed everything down with, and I've put a 150 grit wheel in. This is going to give us a super nice finish that our parents can be proud of. I gave my wheel a quick dress with my diamond dresser just to make it run true and flatten out the surface and smooth out the surface. You see the sparks kind of pulsing there, and basically what's happening is this thing is moving around a tiny bit with the heat and everything, but I mean we're talking so little, almost not measurable, probably a tenth of a thou or something. That may not even go away throughout the finishing process, although it may. That basically all depends on how stable this particular piece of high-speed steel is. I've got this finishing, first finishing pass. The thing's minimum skimmed. It's all cleaned up. So I'm able to get a much more accurate measurement now. And it's measuring about 1 1/4 bigger here than it is here. So what I'm going to do is set my test dial up and adjust my table until I get it running from 0 down here to just a shade better than 1/2 thou plus down at this end. And then that should give me a nice parallel shank. Okay, that's just a little more than 1/2 thou. The thing which is what I was going for, was just a little more than 1/2 thou. The thing about most machining processes is you're never going to get perfect, but you're always trying your best. And I think the trick is, don't give your whole tolerance up on your first setup, because by the time you get through all your setups, you're going to be way out of whack. Keep every single setup, every process as tight as you possibly can, and that'll give you the best possible results. That's super close. I'm happy with that. I'm exactly 2 thou in the diameter over my finish size, so I'm just going to go ahead and finish that up, and then we'll start working on the other end. Didn't really get to show you guys, but this thing did end up running true. It got all of its inner stresses out, and I think you can see by looking here how much better the finish is on the shank area than it is on the roughed out but unfinished cutting area. Now we're going to bring the cutting area down to size. But before I do that, now that I know this is perfectly parallel and runs perfectly true, I'm going to dial it so that I get the slightest bit of taper on the cutting end. I want, no matter what, the back can't be bigger than the front. So I'm going to purposely make it so it's about 1/2 thou-ish, smaller at the back than it is at the front. That'll ensure that only the front cuts, and I'm not trying to cut with all these teeth all at the same time. And then we're going to move on to our next step. We're dialing some pretty small amounts here, but I'm somewhere in the neighborhood of 1/4 thou over the length of my cutting area. So I'm going to go with that. That actually hit running true too. You can see my sparks aren't really pulsing at all. That's a really good sign. That means it's gotten, this piece of high-speed steel has gotten rid of all of its internal stresses, and everything's going to be nice and concentric when we're done this. I've got this cutting area to finish size. That is the size I want the leading edge to be, and if you look closely here, we're about 1/2 thou smaller back there, so about 1/4 thou per side taper. That's exactly what I was shooting for, or plenty close, and so we're going to call that good. We're going to move on to our next setup, which is putting in the flutes. Now the flutes are going to do two different things. They're going to provide an area where the chips can hang out while the tap is making a pass. And just as importantly, they're going to provide us with a rake angle that's super critical to the cutting action. It's an awesome day to be tool and cutter grinding. Just look out there. Very slight change of plans here, only because I was planning to use this machine to put the flutes in. And when I got over here, I realized it's very close to being set up to put a drive square on the end of this shank. So rather than ruin a nearly done setup and then have to redo it all later, I'm going to go ahead and put my square on the shank now, and then that'll be done, and then we'll move on to doing our flutes. So that was super quick to get this set up. All I had to do was get my sensitive work head dialed in, and I already had the right wheel, and yeah, ready to go. I'm going to put that square on there now. I've picked this wheel to make my flutes with, and this is going to be just about perfect. This is actually a 7/16 tap that I'm holding, and we are making a 7/16 tap only because that is best suited to the blank size that I had. So that's why we're doing it. But I figured this way you guys could get right in there and see what we're going to do. Now, of course, on a regular tap, a right-hand tap, this is going to be your cutting edge, your leading edge. But on our left-hand tap, this is going to be our leading edge over here. And so I've picked the side of this wheel, which is going to give us the best rake angle over on that edge. So that's how that's going to go. Using the collet to hold the tap in this setup, and the reason is centers and indexing with an indexing plate really don't go well together, whereas collets and indexing plates, they're buddies. I'm all set to grind these flutes in now, but before we get started, there's one thing I wanted to show you guys down here on the end of the tool. So I'm just going to pull this tailstock off, set it aside for a second, and show you with this square that when I butt it up against the wheel, you can see I'm on this side of center. And because it's a left-hand tool, it's going to cut in this direction. That's where I want my rake to be. So the fact that I'm on this side of center is going to mean I have a positive rake on my cutting edge, and it's going to cut much better. I've been calling this my beater tailstock, and you can see I've been grinding into it all over the place. It's the one that gets all the abuse when things get too tight for what the tailstock's made for. Now, if you've been hanging out with us in recent videos, you've probably heard me talking about wanting to make a low profile tailstock. And I decided the best thing to do would just be to modify this one and make it my low profile tailstock. So I'm going to get rid of a bunch of the meat up here, get rid of all this meat, probably get rid of a bunch of this, might even get rid of this thing altogether, and turn this into a low profile tailstock that would be perfect for the needs I have making a tool like this today. But for now, I'm just going to grind into it some more. Well, there's our flutes done. Again, left-hand tap, so it's going to cut in this direction. This is going to be our leading edge. And I hope it's showing up on camera, but we have a real nice, scoopy, positive rake on the face of that tooth. So I've got my second last setup here kind of roughed in. I'm making a 7/16 diameter, 20 thread per inch plug tap. And the way taps work is a bottoming tap. The lead in is 1.5 teeth long. On a plug tap, it's 5 teeth long, and on a taper tap, it's 9 teeth long. So I'm making a plug tap. I need my lead in to cover 5 teeth. The pitch is 50 thou per tooth. So over a 1/4 inch distance, which I've set on this dial here. Now my double depth of thread is 65 thou. So per side, you're 32.5. So on this dial, you can see I've got my fixture rotated to give me approximately 32.5. It's not bang on, it doesn't need to be, it's fine. And this whole process is a bit of a drawn out thing, and I've been trying to keep this video moving along. I've been trying to keep the boring stuff out of it. But whenever anything pertinent or exciting comes up, I've been wanting to share it with you guys. So if you come around the back for a second here, I've decided I want my tap to have 4 flutes, and I've put 4 flutes in it, so it's a little late to change that now. And of course it'll do right-hand tools, but if you'll notice, it's also capable of left-hand tools. And the way this camming action works is when you're creating a cammed relief, when you're going in the proper direction that the cam is made to for the tool you're working on, during the period where you're grinding the relief, the cam comes in and in and in and in and in kind of slowly, but then it pops out and gets ready to start coming in again on the next tooth. So if you were to use the wrong hand of the cam on the wrong tool, you'd never make it all the way across your lead-in surface with the pop-out part, and that's why it's super important. So I have my 4 flute cam, my L is pointing out, and that's how we are certain we are making a left-hand tool. Another very, very pertinent fact, and I think it's quite interesting, is the tool needs to be timed in with the cam. It can't just be any old place. You need the whole popping out thing to happen when you're not in contact with the workpiece. And so this little line up here is sort of a 0 point, and essentially that's the middle between starting to come out and starting to come in. And so generally speaking, and I normally do this by eye with a real careful check with my dial later, but I've got the center of my flute by eye at center height. And so what that should do for me is, as I come past my cutting edge, I'll be coming in and in and in and in, and then when I'm in my flute, I'll pop out and it'll prepare to start coming in and in again on the next tooth. So I know that was a lot of words, but I think I have a little visual here that might help if that was hard to explain. This dial shows the axial travel of this fixture, and the axial and radial travel, they go together, they match. We know this is a left-hand tool, and so the cutting edge is this guy here. So before a cutting edge gets to center height, and if you notice the shape of the wheels, the wheel sticks out the furthest at center, and that's where things are going to happen. So before the leading edge here gets to the center height of this fixture, we want to see this going minus, just like it is there. That means a relief will be created throughout this lead-in area, and then after the back of this lead-in area passes below center, we're going to see this dial pop back to the positive pretty quick, and it hits its bottom and stops moving before the next leading edge gets down to center height. And then this tooth, as it's passing down through center height, same thing happens. The dial's going minus, minus, minus. That's our clearance being put on, and then pops back out. Hope that makes it clearer for you guys. So fun fact, inevitably in every video we do, somebody's gonna comment, could have just bought a new one easier. Well, that guy's not watching anymore. He stopped a long time ago, and so we can poke a little fun at him now. And clearly that guy just doesn't get what we're doing here. This, however, is one case where that's completely untrue, because using this equipment, we could make any pitch on any diameter we want, assuming they're compatible. We could just create some completely oddball, custom, one-of-a-kind tap if we wanted to. And so that guy who doesn't get it this time, he's also wrong. I put some marker on this one tooth to help demonstrate. Now, since left-hand tool again, the leading edge is over here, what we're going to see is we're going to see the marker come off the trailing edge first, and then that cleaned up area will work its way in this direction and this direction at the same time, and that's going to show that we're creating a clearance. So here, you can see what I'm talking about. It's a much wider cleaned up area here than it is there, and this is also a really good way to make sure that we have our rotation set up correctly and that we're not popping out too soon. The last thing we want to do, well, there's two things we really don't want to do. We don't want to have the front rounded off in the wrong direction. That would make this unusable. We also don't want a big tail on the back, and that would happen if we had it rotated too far in the other direction. And to me, this looks just about right. Just working my way back and forth across that lead-in area as we go around. And I did set my in-feed dial to 0 when I started. Well, there's our lead-in done, and you can clearly see the relief. Here's our cutting edge. Again, left-hand tap is going to cut this way, and relief behind. So just one last thing to do, and that is to put our tooth form in. So this is where the project gets interesting, putting this tooth form in. I'm not honestly set up to do that at all. So to make it happen, we're gonna have to combine 3 machines and some custom rigging together to make it happen. The lathe is gonna drive the whole assembly, and its lead screw is gonna generate our pitch. Cam relieving fixture is gonna be up on the lathe, and it's gonna be doing its job, cam relieving. quality taps have approximately a 2 thou relief from the leading edge to the trailing edge per side. So I'll be dialing that into about 2 thou from there to there. It's also its rotation is gonna allow us to dial in that 1/2 thou taper that we put on this side, if you recall earlier. We're also gonna have to take the head off of the tool and cutter grinder, and it's going to provide us with the grinding action, and it's gonna give us our tooth form. Now, before I take this head off, I am gonna have to dress this wheel out to 60 degrees included so that it can do all that. On top of all that, we're gonna need all this custom rig in here. So the drive shaft is gonna go in the jaws of the chuck on the lathe, and it's gonna drive the camera leaving fixture. These spacers are going to get my camera leaving fixture up to the proper height, because I'm not that good at math. These parts here are going to clamp the camera leaving fixture to the lathe, and this thing here is what the grinding head is going to mount to, and it allows me to adjust the angle of it so I can pick up the pitch angle that's of the thread that we're cutting. There's my thread form done now, and so time for me to start sewing Frankenstein together here. So I thought this was a pretty cool step I wanted to share with you guys. What I'm doing right now, this is the mount for my for the grinding head off of my universal tool and cutter grinder. And it needs to be set at the pitch angle of the thread that I'm grinding. And so what I've done, I calculated it out that it's 2 1/4 degrees. So I've set my protractor as best I could to 2 1/4 degrees, because if you look at a thread from the side, it's going to be going along on an angle essentially. And I want my wheel to be parallel to the thread so that there's no it'll be happier that way.
Okay.
So admittedly, there's a little eyeballing going on here. But what I am eyeballing is the distance between my scale and my 1, 2, 3 blocks, and it looks pretty darn parallel to me. So I'm going to call that good. I think this is important, but I'm only going to get so close to my 2 1/4 degrees here. So I think by eye is fair that I'm doing that by eye. So I'm all set to go here. Now, I do have to explain, I personally have never seen how taps are made in the real world, but I think it's safe that I can guarantee this ain't it.
Nope.
So here's what's going on here. I've got my lathe driving my camera leaving fixture. My camera leaving fixture is doing the camera leaving of the tool. My lead screw is engaged with my split nut, which is driving the carriage in kind of the wrong direction, but of course that'd be the left-hand direction. And so what I'm going to do is make passes with this rotating forwards. I'll be making passes with the wheel traveling in this direction, and I'll just keep advancing it on every pass until I'm at my single depth, and we'll see how she goes. I'm not going to disengage my split nut through this whole thing. I'm going to use my motors forward and reverse to control going back and forth. I'm taking 2 thou depths of cut here per pass. You see how that goes. I'll ease up if I have to. Seems pretty happy. It's a little bit awkward. Normally, you know, you're working on this side with a turning tool or even just a lathe tool. So now in is out and out is in and frontwards is backwards. It's a little bit of a mind thing that ends up going on here. So that's it. She's done. She's out of the machine. I'm partially happy with this. One challenge was that my wheel coming to such a sharp point, that edge was kind of, no matter how careful I was dressing it, that edge was kind of blowing away. So I came in and put the tiniest little flat on there, and that flat, by the time this edge got solid, that flat was bigger than I would have liked it to be. So now at the root of my tap, there's a bigger flat than I would have preferred to have. Now, it will still cut a thread, I'm certain of that, we're going to find out, but it won't cut the exact right thread. I had to stop before I got to the nominal depth because that flat at the bottom meant that my teeth were starting to come to a point at the top, which isn't ideal. So a couple lessons learned there for me, but some tricks for next time. I think one of the tricks would be to find a super, super sharp diamond to do my dressing with. Maybe yeah, I was going to say a CBN wheel, but I can't afford one of those for a YouTube video. So well, let's see how she cuts. So I've drilled a hole here, and this is aluminum, a little 3/8 piece of aluminum, and I've drilled a tap hole in it. Let's see how she taps. It seemed to cut pretty decent. It is just aluminum, but still, if it didn't want to go, you'd be able to feel it. So it cut some pretty decent threads. I kind of doubt a standard bolt might go in there. I mean, it might, but we know it's not perfect, but it certainly worked. And I hope you guys enjoyed watching. We certainly enjoyed doing this. Well, thanks for watching, everybody. Bye for now. We'll see you in the next one.